So here's a good summary of the process. We want to find the leading term and determine the end behavior, find the y-intercept, the x-intercepts and determine their multiplicity, plot the points, and connect carefully. All right, so on this one, notice it's not in factored form, but that's okay. Our leading term, that's easy. Our leading term is negative 3x to the fourth. So again, this is even, so that means it behaves the same, but that's negative. So the graph goes down on both sides. Then the y-intercept. So again, we're plugging in 0 for x. And I'm going to get 0. That was pretty easy. So now do the x-intercepts. So I set the function equal to 0. It is not factored, so you have to factor it. This is just a greatest common factor. I think I'm going to take out a negative 3x cubed. And remember, when you're taking out or factoring out, you're just dividing each term. So I'm really dividing that first term by negative 3x cubed. And that's going to leave me positive x. And then I'm going to divide this. And that's going to leave me negative 1. So now we need to set each factor equal to 0 and solve. So here I divide by negative 3, I still get 0. Take the cube root, I still get 0. And here I have a 1. But now I need to state the multiplicity. This really was x times x times x. I really had 3 of those. So this is triple, or a multiplicity of 3. And this is a single. All right, so now we need to graph. Okay, so I've got down on both sides. I've got my y-intercept at 0, also x-intercept, and 1. Okay, so again, I'm going to start here. 1 is single, so it's got to come up and just pass through. Now it's got to come back down and go through 0, and it's got a squiggle. So again, you're up here, you're going to come down, and again, a squiggle. So just practice that and that. You'll get it. So again, not a pretty graph. If you graph it on a graphing calculator, it might not look exactly like that, but this is close enough. Again, in behavior, the intercepts, and how does it behave at those intercepts. That's the important part. Now, the best thing to do is stop the video and try this problem on your own, and then come back and see if you got it right. So my leading term is 4x to the fourth, even, positive, both up. So up, up. Y-intercept. At negative 1. And when you put those on the graph, label them. Okay, and again, don't try to use graph paper. That's not going to work. Okay, and now we have to set the function equal to 0. This needs to be factored. It's a trinomial. We practiced that on the very first lesson of the semester. So I'm checking my signs. I think that's good. Okay, so now if I set both of those equal to 0, now keep in mind those were single. That parenthesis was raised to the first power. So I'm going to set that equal to 0. Let's see what happens. If I subtract 1 and divide by 4, okay, haven't done anything wrong. And when I take the square root, what happens when you take the square root of something negative? You get a non-real number. We call it imaginary. But these are real functions, not useful. This is not an x-intercept. But let's look at this one. X squared minus 1 equal to 0. X squared equals to 1. Take that square root and you get plus or minus 1. And again, those are single roots. So a negative 1 and a positive 1. And again, the graph is just going to pass through there. Okay, so we start up here. We got to come down through 1. We got to get to negative 1 there. We got to come back up. So almost looks like a parabola. In fact, Most graphs that are x to the fourth usually do look like a parabola slightly. And again, that's all we need to do. Okay, on this graph, again, I would say stop the video and try it on your own. I need my leading term. Okay, so I've got to take my 3x all squared and x all squared. Okay, again, even and positive, so both up. Let x be 0. And I get positive 1 for my y-intercept. And this one is nice because it's factored for us, so that should be easy. So I set the function equal to 0. And because those are squared, I know that each of those is a double or a multiplicity of 2, and that means it's going to bounce. So let's go ahead. So I have 3x minus 1 equals to 0. So x is going to be 1/3. And this is what I call a double or a multiplicity of 2. And then I have x is equal to -1. And again, a double or a multiplicity of 2. Okay, so I have a 1/3. And again, this is not to scale, so don't worry about that. Remember, a double is going to bounce. So if I'm up here and I'm going to go down to 1/3, it's got to do that. That's the only way I'm going to end up. And then it's got to pass through my y-intercept, and it's got to bounce again. That's pretty much it. One thing you can check is that when you graph it, look at your x-axis. If your graph has passed through the x-axis at other places besides what you have found, then you've made a mistake. So just be careful. Let's do another one. So leading term, that's easy, 4x cubed. So that's odd, that's positive. So remember, up and down. Okay, up on the right, down on the left. Okay, y-intercept, let x be 0. And I'm going to get 0. Okay, so I've got up and I've got down. And we need to set this equal to 0, and unfortunately I have to factor. But again, it's just a greatest common factor. Looks like 4x. And now I have two factors. And remember, those are both single. So I have 4x equal to 0 and x minus 3 is equal to 0. So x is 0, which makes sense. I've got to get it both ways. But here, when I take the square root, I get plus or minus the square root of 3. That is a real number. It's not pretty, but it's a real number that needs to go on the graph. So we have positive square root of 3 and negative square root of 3. And those are all single. So the graph is just going to pass through those points. Okay, so we're up here. I've got to come back down. And how far down do I go? Do I go way down here and come up? Or do I just go down here a little bit? I don't know, and it doesn't matter. So I'm just going to go down a little bit and come back up and then come back down. Kind of like a roller coaster. So I think I'm just going to erase this part because I didn't like the way that looked. But until I actually plot additional points or look at a graphing utility, I really don't know, does this graph, do way down and way up? I don't know. But what I just drew was not a function because it's so curvy, it fails the vertical line test. So be careful, be neat, and make sure that your picture, your graph, is indeed a function. And again, here are some good steps to remember, but also the directions of the homework and any problems on the test are going to have you find the leading term, find the end behavior. I'm going to say find the y-intercept. I'm going to say find the x-intercepts and determine the multiplicity. And then I'm going to say graph. So this isn't something you have to memorize. You just have to know how to do the process.